The gravitational field strength, as we said previously, it is also known as the acceleration caused by gravity. But it is, when we're talking about forces, the force per kilogram, or then how many newtons per kilogram. How many newtons a kilogram of mass would experience. So we have our force of gravity formula, the first one. Now let's take a look at the gravitational field strength formula. If we rearrange this equation, solving for g, we get little g is the force of gravity divided by mass. But there is a second version, just like there are two formulas for the force of gravity. There's two formulas for the gravitational field strength. And the other one is the gravitational field strength is this big G. But basically what it says is it depends on the mass of the larger body, like the Earth, and how far apart you are from it. We saw that already, that if we have the Earth, and this is at the center of the Earth, and this is the surface of the Earth, as you go farther and farther away, we expect the force of gravity to decrease. And then we also expect the gravitational field strength to decrease. We would expect the acceleration you would experience because of gravity, caused by gravity, to be less. So gravity decreases as you move further out. We operate at this particular distance, at this particular r. And at that particular r, the gravitational field strength is 9.80665 newtons per kilogram. But if we go farther out, it'll be less. It will get to be like 9 and 8 and so on. And if we went inward, it would get larger, like 11 and 12 and so forth. It would increase as we went toward the center of the Earth. So the gravitational field strength is this little value g, and it is a variable. But since almost all instances that we study in a particular course may be at the surface of the Earth, we use this one value. But it's important for us to realize that the value does decrease as we move out from the center of the Earth, and it increases as we move further in. The other thing for us to note is that in this scale diagram, and if we were to draw both the tallest height that airplanes fly, commercial airliners fly, 37,000 feet, or about 11,000 meters, and the deepest parts of the ocean, which are also about 11,000 meters. That distance is thinner than the representation in this black line. The Earth is so large, and if we were to consider from the airplane to the bottom of the sea, and then we have sea level in between, it is less than the thickness of this black line. So what you can see then is that R does not change very much for almost all human endeavor. For most human endeavor, G does not change. It is very close to this number, and that's an important thing to remember. We need to remember where we are. If we are anywhere near the surface of the Earth, this is the value.